Chapter 1, Section 6. Your learning target for this lesson is multiplying and dividing real numbers. We've talked about products and quotients before. Let's just review that real quick. It says here at number 1, how is a product different from a quotient? Well, products, I'll put prod here, is really when you multiply. And a quotient, I'll put quo here, really is when you divide. So that's what we have to know about products and quotients. And number 2, it says circle the product of 12 and 4. All right, we want to circle the product of 12 and 4. Obviously, I'm not going to do that on here, but what is, product is times, so what's 12 times 4? If we figured it out, we would have 48 as, that isn't working for me, 48 as the product. Underline the quotient of 12 and 4. That's 12 divided by 4, and we know that is to be 3. So we know what products and we know what quotients are. Let's get into what a reciprocal is. Now, we worked on reciprocals last chapter. We're adding and subtracting, and we knew that the reciprocal of a number when we added it or subtract it was the negative of it. But in multiplication and division, or products and quotients, the reciprocal is a little bit different. Let's take a look at 3/4. This is a great one to take a look at what the reciprocal of 3/4 is. Now, I guess before I want to start on this, a reciprocal, when we multiply a number times its reciprocal, it's going to equal 1. So we have to multiply this by something so it equals 1. And the reciprocal of 3/4 is 4/3. We just take the 4 and we put it on top and we put the 3 on the bottom. Does that work out? Well, let's take a look. Let's erase this 1 here. And let's say 3 times 4 is 12. 4 times 3 is 12. And 12 over 12 equals 1. So yes, the reciprocal of 3/4 is 4/3. If we look at number 3, we look at column A and column B. Now the first one we've got here is 3/4. Where is the reciprocal to that? Well, we already figured it out. It's 4/3. Okay? Now, what is the reciprocal to 1/2? Let's take a look at that once. Because if this works out, we should equal 1 over here, right? So 1/2, the reciprocal of that is really, put the 2 on top and a 1 on the bottom. And that would equal 2 over 2, right? 1 times 2 is 2, and 2 times 1 is 2, which would equal 1. Do you see 2 over 1 in column B anywhere? No, you won't, because 2 over 1 is actually the same as saying just 2, right? So we take a look in column B, and we see 2 right here. There would be the answer. -2. Now this is interesting again. If we take -2, and we look at its reciprocal. Well, what is the reciprocal of -2? There's nothing in the denominator here. But yes, there really is, because we can put this over 1, right? The same as we could take 2 over 1 before and say it's 2. -2 over 1 is really 2. So the reciprocal of this is going to be 1 over a -2. Does that equal 1? Well, let's take a look. -2 times 1 is -2. 1 times -2 is -2, which equals 1, so that's the reciprocal. So the reciprocal for -2 is a -1/2, which is right here. All right? Let's take a look at 1 3/4. This is getting a little bit more difficult. What is the reciprocal of 1 3/4? Before we can find the reciprocal of 1 3/4, we need to make this into just a fraction. All right? And the way we do that is we multiply the 4 times the 1 and add it to 3. And then that would go on top. So 4 times 1 is 4, plus 3 equals 7/4. That's the same as saying 1 3/4. Now what's the reciprocal of 3/4 or 7/4? Well, we switch them around. It's 4/7, which equals 1 if you multiply these together. Do we have 4/7 out here? Sure we do right here. That is the reciprocal to 1 3/4. And then the last one is -5/3. If we flip it around, we find that the reciprocal to that one is -3/5. Let's take a look at the concept of multiplying and dividing real numbers. Now this is real numbers with different signs and the same signs, and we're going to learn a little bit about how we do this. It says here, the product or quotient of two real numbers with different signs is negative. What does that mean? It means that if I have a plus times a negative, this will always be negative. Or a negative times a plus will always be negative. When we have two different signs multiplying together, the result is always negative. But what happens when the signs are the same? It doesn't matter if we have pluses. Plus times a plus is going to equal a plus, right? And a negative times a negative equals a plus. So if the signs are the same, the result is always going to be plus. Now when we're dealing with multiplication or products, it doesn't matter what we multiply it by, we're going to come up with an answer. But when we have a quotient, when we are dividing by something, we have to remember this. We can never, and I'm going to say this, never divide by 0. Okay? Never can we divide by 0 because the result of this, I don't care what number is out here, the result of this is undefined. Undefined. So we can never do this. We can never divide by 0. If we take a look at number 4, let's take a look at what these would represent, the signs, if we were to multiply these together or find the quotient. The first one is 5 times a -9. Positive times a negative is always a negative. All right? Take a look at the next one, -8 times a -2. We have two of the same sign, so it's always positive. Let's take a look at number 3. We have 0 divided by 9. Okay, this is 0 divided by 9. If we were going to rewrite this, it could be 0 over 9. Well, in this case, it's always 0. When there's a 0 on top and some number other than 0 on the bottom, the result is always 0. But then this one, 9 divided by 0. Well, we just went over that. You can never have 9 divided by 0. What is that? That is undefined. All right, so you got a good idea of how to use your different signs. Let's go ahead and let's work on some problems. At the top, problem 1, it says 6. We're going to find the product of each, and it says 6 times a -15. Well, first off, we know it's a positive and negative, so this number is going to be negative. 6 times 15 is, well, 6 times 1 is 6, or 60, because it's really 6 times 10, and 6 times 5 is 30, so 30 plus 60 is 90. Let's take a look at the next one. 12 times 0.2. Well, what's 12 times 2? 12 times 2 is 24, right? But we have one decimal in here. So we're going to move the decimal over 1. So 12 times 0.2 is 2.4. Let's take a look at a -7/10 times 3/5. Well, we know right now we have a negative times a positive, so this is going to be negative. 7 times 3 is 21 over 10 times 5, which is 50. There would be our number. negative 21 fiftieths. The next one is a negative 4 squared. Well, that's the same as saying negative 4 times negative 4. Since they're both negative, we know it's going to be a positive number here, and 4 times 4 is 16. This next portion is going to be really important. If you're not paying attention coming into this part, I want you to start paying attention on this one. Do you hear me? Start paying attention. All right. It's called multiplicative, and I'm going to just inverse. Multiplicative inverse. This is going to be a really important one. Multiplicative inverse says, and we've done this before, if we had 1 over a, what's the multiplicative inverse of this? Well, the multiplicative inverse of this is a over 1, right? But this is where it becomes really important. All right, let me go ahead and erase this. Every one of us have seen things where we have multiplied fractions, right? We've done 3/4 times 2/5, right? We knew how to do that because 3 times 2 is 6. We go across top and then we multiply the denominators. 4 times 5 is 20. And actually in this case we'd want to reduce it, right? We could take a 2 out of both of these, so this would reduce to 3/10. But what happens if I say 3/4 divided by 2/5? Whoa, that's a tough one. You know, we could rewrite this as 3/4 over 2/5. But that doesn't make it any easier, does it? So what will we do? Well, here's where your multiplicative inverse comes in. And here's what you can do when you're dividing with fractions. I can take this fraction right here and put its multiplicative inverse in it and then multiply by it. So if that's the case, I can go 3/4 times, now we're going to change the sign from dividing to times, and we put the multiplicative inverse in for 2/5. 5/2. Now we can multiply it through. 3 times 5 is 15, and 4 times 2 is 8. That is really this right here. 3/4 divided by 2/5 is 15 divided by 8. The way we did it is we flipped this one here, made a multiplicative inverse of it, and then multiplied it, and that's how we quickly come up with it. Let's try that one more time. Let's say we have 7/9 divided by 1/3. Can we come up with a multiplicative inverse for this? Yeah, it's pretty easy. 7/9 times 3 over 1. Well, 7 times 3 is 21 over 9. Can we reduce this? Well, sure we can. We can take a 3 out of both of these, and this would equal 7/3. That right here is the result of this right here. Taking 7/9 divided by 1/3 equals 7/3.